Okay, hopefully I didn't take too long to get started this time. So we can make our pick. You know, we can use this one here, or this one here. Um, Even this one, right? Now, what we're going to be noticing is that this is the a in the ax squared plus bx plus c, right? This is the b, and this is our c, right? So our a is going to be 10, positive 10, c is going to be negative 7. But you don't, when it comes to the AC method, right? So let me just draw something here. This here, that word right there, or not so much a word, but you know, the conjunction of words there, right? AC method, right? So it focuses on the very first coefficient of the first term and, well, the C itself, right? So therefore, the coefficient of x squared, which is A, and of course, the third term, C, right? Now, let us say we were to multiply 10 by 7. That would result in us having, oh, oh, I was using the wrong tool. Let me do that again. Let me use a line. So we'll have, let's go to, so that's going to be 70, right? Now, what we would attempt to do is we would need, we would need, we would need two factors of 70 that can give us something that looks like minus 33 right there. Now, let's look at 70. 70 is 7 times 10. So if we're looking at all the prime numbers there, it would be 2 by 5 by 7. Now, there are, well, I want to say that contextually correctly, right? This is what we have currently. If we were to group it like this, 2 times 5 would be 10 by 7. Seeing that this will not give us what we're looking for, right? We cannot use 10 and 7. There's no combination of 10 and 7 that will ever give us 33. Whether you want to use plus 10 plus 7 or minus 10 minus 7, you will either have a positive or a negative 17, right? That's what you would get there, right? Either a positive or a negative 17. And if you were to do a subtraction, you would either have a positive or a negative 3, right? So just to put that out there, right? So those are your options for using 10 and 7 as your factors of 70. So we have to rule out the 10 and 7. So what about 2 times 7, which is 14 times 5? No, that would result in 14 plus 5, giving you 19, or 14 minus 5, which is going to be 9. So 14 or 9, it's nowhere near the 33, right? So that means that if we were to consider 14 by 5 or 10 by 7, we would have to rule those two out, right? So we would have to rule them out, right? So 14 by 5, nope. 10 by 7, no. So there's only one option left. And that option would be 7 by 5 is 35. So what could we do with 35 and 2? We could either have a plus 35 and a minus 2, or we could have a minus 35 and a plus 2. So it is really up to us to make the right decision where this is concerned, right? So let me get rid of this right here. So let's put the x's beside each of these numbers here. Now, typically, this is what I say to my students. When the larger number, 35, is positive, the outcome is positive. Therefore, 35 minus 2 will be positive 33x. Seeing that we want a negative value, we will have to rule that one out. So it will have to be minus 35x plus 2x, right? So what we would have to do is we would have to have 10x squared. You would have your 35x. You would have your 2x and your 7. Okay, give me a second. Okay, so yeah, if you're hearing some, yeah, okay. That's Benny for those of you who are hearing that. That's my dog that's decided that he's going to stay in my room. So why not? Okay, so let's have a look at the sign. So we're going to have a minus 35 plus 2x and minus 7, right? Now, what is happening here, just so that we have everything in context, all of this here replaces what is going on right here, right? So just want to be confident of that choice that we made right there, right? So just to put that in order now. So the only thing we have left to do is to factorize both sides, right? That's what we need to do. So let's put down a bracket here and a bracket here. Now, 10 and 35. It's pretty obvious what the HCF of this is going to be. Both of them end with 0 or 5. So it's pretty easy to say that, you know, it would include 5. So let's see, 2 times 5 and 5 times 7. Give me 1 second while I try to get this dog out of my room. All right, so I was in the middle of writing my multiplication signs. So here we go, right? So naturally the HCF of 10 and 35 must be 5. And of course, the HCF of x squared and x is going to be x. So you naturally would have an x out there. And you're just going to put a 5 in front of all of this, right? Yeah, the x looks tiny. We'll just rewrite that. So let's do this again. So we have 5 here and our x right here. Here we go. All right. We divide 10x squared by 5x. We are going to have, let's see, we're going to have 10x by x over just 5x. The x's disappear, giving you away 10 over 5. That will be 2x. All right, so we'll have 2x right here. And of course, 35 over 5 is 7. X over x is 1. 7 times 1, that's going to be 7. Now, whatever you get in the left bracket, you will also get in the right. So there's no guesswork where that's concerned. Once you have a middle term that can be broken into the two, you know for a fact that you will appear with this left bracket and the right bracket will have the exact same value. So if you have 2x minus 7 over here, you will get that over here as well. So you don't even need to guess that part. So now all we need to do is divide 2x by 2x or minus 7 by minus 7. That is going to give us a positive 1. Right? Because this would have been the difficult part. What number could you possibly factorize out of 2x minus 7? You would have to use 1. So now we have the 5x that we can put here and the plus 1 we can put here, right? So we'll have our 5x plus 1, and then we are going to have our 2x minus 7. So bracket this, bracket that, bracket this, bracket that. And that is how we factorize 10x squared minus 33x minus 7, right? Now, the beauty about this term here is that this number was prime. So the only possibilities for the factors of 7 would be 7 and 1 because the number is prime. The number is prime. You would have had no other choices but to use 7 and 1, right? So that's why you can see the 7 here and the 1 right here, right? So it is showing us that 7 is a proper prime number. So whenever we get a prime number on the end over here, it makes the factorizing a lot easier to do, right? So hopefully I can leave this for you to look at, right? Hopefully you can remember all the steps, because what we're gonna do, I'll pick a harder one to do. I'll pick the one that's a little bit more challenging to do. So let's do the one that says 56x squared plus 11x minus 15. Let's do this one. All right, now look very, very carefully now. All right, the A is going to be 56, the C is going to be 15. So let's see what happens here. We have a 56, we have a 15. Typically, you would and you should multiply the 56 by the 15. And I will. But the way that I plan to go about doing it is to break them down into their prime numbers, right? Why? We'll find out in a minute, right? 7 times 8 means we will have 2 times 2 times 2 times 7. And this means we will have 3 times 5 over here, right? So 222, 17, and a 3 by 5. So now we have to figure out what combination of these factors will result in us having a positive or a negative 11. Because there are only two possibilities, a positive and a negative 11, right? So let's see what we have here. No, naturally the 56 and 15 will not work, right? The difference between 56 and 15 is going to be 41. So we can't use 56 and 15, right? So we can't group it the way that we got there, right? So we have to find a way to group 3 with 7 or 5 with 7. We have to find something that's going to work, right? Now, we can't avoid the trial and error, right? So let's try 3 by 7. All right, that's going to give us 21, leaving us with 5 times 8. It's going to leave us with 40. Now, this would be nice if this number was 19, whether it was plus or negative 19. So that would be perfect. So therefore, we would either have a minus 40 plus 21 or a plus 40 minus 21, right? So therefore, it's telling us that the combination of 21 and 40 is not going to work, right? That's not going to work. So we're probably going to have to wrap this one up, right? So we can't use the 40 and the 21. So is there anything else we can use? All right, fine. Let's try this. This will give us 21 times 2, 42. So we'll have 42. And we will have 5 times 2, 10 times 2, 20. So we'll have 42 and 20. Now, this cannot work. Why? Because we will only get 22 in the middle, but not 11. So we can't use this combination either, right? So I'm getting the feeling we're going to have to combine 5 with 7, right? It's probably the only thing that would give us something large enough where it would help us to find out a factor. So let's see what we can do with this. 5 by 7. Okay. That gives us, let's see here. Let's put the 35 over here. Now, what number would we get when we have, okay, 8 times 3. Or 3 times 2, 6 times 2, 12 times 2, 24. There we go. This is what we've been looking for. Now, it can't be 2 pluses nor 2 minuses. So we are going to go with a plus. Hold on. Yes, forgive me for the muting. Right, so now we have what we need. We will have a, all right, let me use a different color here. Use a different color here so that we can have a, so we'll have a plus 35x. We'll have a minus 24x. This will result in a positive 11x, right? So that to me, ladies and gentlemen, is the beauty of understanding your prime numbers. And this is the sort of thing that I've been utilizing prime numbers from as early as those who are doing, you know, mathematics in PEP all the way up to the CSEC level. Your prime numbers will never let you down. Your prime numbers will never fail you. Because had it not been for these prime numbers, I would not have considered all of these possible combinations in order to give us different factors, right? It's the safest way to mix and match until you get, you know, different numbers, right? Because I tried 3 and 7 and that gave me 21, right? So that wasn't too bad. But then I tried 5 and 7 and that gave us something better, right? So with that said, now we're going to replace this 11x right here, this one. We're going to replace the plus 11x with the, let me just highlight it. We're going to replace it with plus 35x and minus 24x, right? So we're going to write all of that so we can actually see how that would work. All right, so let's do that. So we're gonna have 56x squared. We're gonna have 35x. We're gonna have 24x, and we're gonna have 15. So let's look at the signs we're going to have now. This is going to be a plus 35x. This will be a minus 24x. This will be a minus 15. And we have successfully replaced the plus 11x with our plus 35 minus 24x, right? So let us not forget what the goal is. We're trying to turn the middle term into two terms, and then we can factorize two pairs of terms, right? And then when we do this, we will get the two factors that gave us the original question in the first place, right? Okay, so I think the hard part is over. We can just bask at our excellence for a little bit, right? So what do we do at this point? What do we do? Well, we're going to do what we normally do, right? We're going to put a little bracket here, and a little bracket here, a little bracket here, and a little bracket here. And why not? Let's change the numbers from, well, okay, we still have a 35, so no need to completely undo everything over here. We have 56 and 35. So this will be 7 by the triple 2, right? 7 by 2 to the 3. This will be 7 times 5. So seeing that they have nothing else in common but the 7, it's safe to say that the HCF of the two lines is going to be 7, right? So see, the basics will never fail you. Right? People think that, oh, LCM and HCF, that's for primary school. But no, we need our knowledge of multiples and factors all the way up to this level. Because even when we're using simultaneous equations, whenever we're going to make the coefficients of x and y equal to each other, we need to find the LCM, right? We need to find the LCM. And so the LCM and the HCF, if we have a working knowledge of getting it very easily, then why not do it, right? So this is what is common to both. The HCF must be 7 And as a result, I will be putting that number. Wait. All right. Hold on. I'm using the wrong tool. So, yeah, pardon that. So we'll have 7 on the outside. And of course, the HCF of x and x squared is going to be x. So we'll have 7x right there. So x squared over x will leave us with just x. 56 over 7 is 8. This will leave us with 8 and an x by itself. Now, just in case you're not feeling confident about that, multiply 8 by 7, you'll get 56. Multiply x by x to get x squared. So if you ever come here and you see something like this, if you multiply 7x by the 8 and you don't get this up here, then you know that something is missing, right? So sometimes you don't need to be, absolutely perfect. But whenever you do notice something strange, you can help yourself out by doing the multiplication so that you can actually see what took place. Now, 35 over 7. Well, we didn't we never circled the 5. So if we divide 35 by 7, it's just going to leave us with 5. So here we go. Whoops. I want to write that properly. And funny enough, I wonder if we notice this. So let's pay attention to this for a minute. Notice we didn't underline, or rather, we didn't circle the 2 to the 3. But 2 to the 3 is the same as 8. And we didn't use the 5, but the 5 is what the second term is right here. So that's a little bit neat, right? So bear that in mind. Now let's have some fun. This, what we have on the left, must also appear on our right, right? And again, this is entirely true as long as you have the middle term. Once the middle term can be broken into these two, then what you get in the bracket on the left will be the same as on the right. So we only have one thing left. Minus 15 divided by a positive 5. What would that be? Minus 15 over a positive 5. Well, once you have a difference in signs, the number will come out negative. So the result is going to be negative 15 over 5. That will be 3. So out here, you're going to have negative, and I have negative 3. Now, how do you know this should not be an x right here? Because if you put an x here and you multiply 3x by 8x, you'll get 24x squared, which is not the case up here. So these are the ways that you can, eliminate making, any additional mistakes, right? So what are we going to be doing now? We're going to be putting the 7x down here. We're going to be putting the minus 3 down here. And then, of course, the 8x plus 5 in bracket will go beside it, right? So let me set that up. All right, so we have 8x plus 5 on this side here. And then the 7x minus 3 goes beside it. So get rid of those arrows there. So we will have this bracket here. Give me a second. All right, there we go. All right, so what we will have here is our 7x and our minus 3. So let's see if everything works out. 7x by 8x, 56x squared. 7x times plus 5 plus 35x minus 3 times 8x minus 24x minus 3 times plus 5 is minus 15. There you have it, right? There you have it. So let's hold on. There's something that I need to check out. Okay, all right. So I was just checking something with the volume. So yeah, that is our second attempt. So I don't know. Usually when I'm not using my tablet this time around. So when I'm using my tablet, what typically happens is I will be taking screenshots of everything that you see here, right? But because I'm not using the tablet, it's a little bit different. You know, the tablet makes the screenshot experience a lot easier to do. So there's that. Yeah, I'm gonna just get rid of a few of these things. So let's have a look at what we've done so far. So far we have managed to do, let me draw a line through what we've done. Got rid of this and we got rid of this. So the others don't look as difficult, right? And I am a little bit, what's the word now? I'm a little bit concerned that, I had some pictures that had a lot more of these questions, like the more complex ones, right? I wanted to do a few of those because I wanted to show that, no matter how difficult it is, we can always find the factors that we need, right? And of course, if you take a look at what we have here, I mean, let's just call a spade a spade. This is a prime number, so you don't have to worry about 3. This here consists of 2 times 5. This here consists of 3 times 5. So you only have prime factors that are smaller than 15 and 1, prime factors that are smaller than 10 and 1, but this number is a prime number, right? So these examples over here will be incredibly easy to do, right? But you know what? Let's pick the most difficult one out of the lot. So this is going to be easy. That's going to be easy. So let's forget about these, right? Let's try these two, right? What could we use to get 18 and 10 to give us a minus 3? How could we possibly get that? All right, so remember, what is A? A is going to be 18, right? And C is going to be 10 right here. So let's remember that, the first and the third, A, C, right? First and the third. So let's bear that in mind. So we are going to be looking at 18 and 10. Okay, 18 and 10. Do we need to multiply? I mean, sure, you could, but I typically don't. At least not in the traditional sense anyway. I'm not going to multiply 18 by 10 to give me 180 and then find the factors of 180. No, I have a better idea. Let's find the factors of 18 and 10 individually. 2 times 9, let's break that down into 2 times 3 times 3. These are my prime factors of 18. And of course, 2 times 5 will give me 10. Right? So, why not? 2 by 3 by 3 and a 2 by 5. Why not? So what combination would give us a -3 right here? So let's see. Let's start by using 5 times 3. That will give us 15. And then we'll have 2 by 2 by 3. Oh my God, it was spot on. I thought I was going to do a lot more trial and error, but we got it right the first time. We didn't even need to waste our time with 3 by 3, 9, 9 times 5, 45, and 45 minus 4. Nah, we never even made that mistake. We just went straight for the 5 times 3. All right, so we got 15. Then now what we have is 2 by 3 by 2, right? So we'll have this multiplied by this. That's going to give us 12, right? The magic number is 223, right? So whenever you want to remember the prime numbers that give you 12, just remember it's 2 times 2 times 3, right? The magic 3. So this will give you this. Much like the 3 by 5 will give you this. All right? So we have what we need. We get the 15 and we get the 12. The only thing we need to do is to write the correct, we need to write the correct signs. So let's put the signs together. If we want a -3, we're going to need the larger number to be negative. So -15 plus 12. Then we put an X in front of these numbers here. And that's it. So we are going to be replacing this -3x with -15x plus 12x. All right. So I think we can see what's going to happen now. Let me decide on the ink that I'm going to use. So we'll have 18 18x squared. We will have 15x. We will have 12x. And we will also have our 10. So let's use what we know. -15 plus 12 minus 10. All right, so let's see what's going to happen here. All right, so well, what is the HCF of what? 18 and 15? Let's put that together and see what we have. We have an 18, we have a 15. What do we get here? What do we get? What do we get? What do we get? See, I don't like guessing and spelling. Don't like it. So we will have, oops, sorry about that. I was using the line. 2 by 3 by 3. And you have 3 by 5. So this is the clearest indication of what the HCF is going to be. All right. So our HCF is going to be, yep, it's going to be 3. So we did not circle the 2 and the 3. 2 times 3 is going to be 6. So we can save ourselves the trouble. We can write in here 6x right here. And what we have here is the 5. So we can put the 5 right here. And seeing that nothing caused a change in this bracket, we're going to put down the minus sign where it was. Right? And then the 3 goes on outside. But fine. Let's say we made the mistake of just writing the 3. right? Let's say we did that. Let's say we made that mistake and all we did was write the 3. 3 times 6x is 18x, so we know that that's not correct. 3 times 5 will give us 15. So that alone will tell us that we need to have 3x. Now, naturally, what do we do here? We have what we have in this bracket, we're putting over this bracket over here. So we have 6x minus 5. No problems there. So we only have one thing left. 12x divided by 6x, fairly easy. Or minus 10 divided by minus 5. Minus 10 divided by minus 5. When the signs are the same, right? And we're dividing, it comes out positive. So it's going to be a plus. 10 divided by 5, we will have a plus 2. So let's write it, 3x plus 2, 6x minus 5. So there you go. And we don't have any doubt in our mind that this is done correctly. Because if we were to do the reverse, which is the binomial expansion, 3x times 6x will give us 18x squared. 3x times minus 5 will give us minus 15x. 2, or a positive 2 times 6x will give us plus 12x. And plus 2 times minus 5 is minus 10. So there we have it. So, did it again. Did it again. Did it again. So that means we can take our line and have it drawn right through this one. This question right here. Right? So let me move. Well, I'm gonna remove this. But I'll just, have us look at it for a little bit. All right. So the most important thing is that we get the 1, 2, 3, 4 terms so that we can factorize them. Once we get the 4 terms, then everything else works out. All right. Okay. So let's just, there we go. All right. So we got rid of 3 of them. All right. We got rid of this one, got rid of this one, got rid of this one. So do we do this or do we do this one? Which one of them should we do? Well, hopefully I will have more of an audience the more often I do these live streams, hopefully, right? So maybe I would have a vote casted by some of the students that would be watching. So, 3 and 10, and a combination of them will give you 13. That's interesting. I see it now. I see how we get 13, but it's not easy to see. Without the prime numbers, there's no way you could know, right? The prime numbers of 10 would be 2, times 5. And of course, if we were to do AC, 10 times 3 would be 30. So you would have 2 times 3 times 5. So what you would have to do is, well, if you combine 3 and 2, you'd have 6 and 5. There's no way 6 and 5 can ever give you 13, because you'd have to add them, and 2 plus signs will not give you a plus and a minus. So this combination will not work. 3 and 2 would never work. But what about 3 times 5? 3 times 5, that's 15. 15 minus 2 will give you 13, right? So this one wasn't so difficult to find out. So therefore, you would have a plus 15x and a minus 2x in the middle for this one here. So that one, you know, we don't need to do that. Let's do this one here and then this one here. And then we'll just wrap everything up after that. So we'll have 36 and 15. Why not? 36 and 15. Now the beauty about this is 15 consists of what? Prime factors. So it's only going to be 3 and 5. It's going to be 3 by 5. Now, you can say 12 times 3, which is fine because 12 is 223. So 12 times 3, it means you'll have 223 in front of another 3. So 2, 2, 3, which is 12, multiplied by 3 will give us 36. So therefore, 36 will be 2233. Also, this is 4 times 9, so there you go. Now, what combination could we possibly use to give ourselves 7x in the middle here? What could we use? Well, the 15 didn't work. The 15 did not work. Ah, ha, 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 ha. There's almost a dead giveaway. Let's look at this for a minute. 3 by 3 by 3 results in 9 times 3. That will give me 27. 5 by 2 by 2, 5 times 2, 10 times 2, 20. There we go. We could not use 2 plus signs or 2 minus signs, right? We just can't. Because you will either get positive or a negative 47, right? So we're going in the wrong direction if we use 2 positives and 2 negatives, right? However, if one is positive and one is negative, we have to make sure that 27 is positive and 20 is negative. By doing this, we end up with a positive 7x. So what would we do? We would replace 7x with plus 27x minus 20x. Right? So let's not forget the work that we did here. Right? So we're just going to look at this for a while. All right. I like to enjoy the spoils. So I'm a little bit hesitant to move forward. So I'm going to do it all the same. So let us write 36 x squared. Then write 27x. Then write 20x and then write, remember it's this question, so 36x squared, we replace these two, or rather replacing this with the 27x and 20x, so we're going to be using 15. So plus 27x minus 20x minus 50. Okay, let me just get rid of this. And I'm getting confused over there. So I'm just going to move this and just put the numbers over here. Seeing that there's a lot more white space over here. So let's switch to that. So 36x squared, 27x, 20x, and of course 15. Right? So we're gonna have a plus here, minus here, and a minus here. So why not drop the brackets? All right, so we're gonna have a plus sign here. Funny enough, whatever sign you have in here, you'll also have in here. And how do I know this? Because what you get in here, you will definitely get in here. So you won't get a plus here and a minus here. Both sides. So if you get a positive here, it's positive here. Negative here, negative here. The only sign that will differ is maybe this sign over here, right? But we'll get to that in a minute. Now we have 36 and we have 27. So let's see what we can do with that. So 36 and 27. All right. We'll have a 2 by a 2 by a 3 by a 3. And we'll have 3 by 3 by 3. So pretty obvious what the HCF is going to be. The HCF is going to look a lot like 3 by 3. So the HCF is going to be 9, right? And of course, the HCF of x and x squared is x. So we will have 9x on the outside. All right, now what did we not select? We didn't select 2 by 2, so we're going to have 4 over here. But 9x times 4 is 36x, so we need an x beside the 4. Now this is perfect. And then we did not include the 3, so we'll just put the 3 right here. So even something as primary school as this can help you with factorizing perfectly. And then 4x plus 3, we just write it again. 4x plus 3. Divide minus 15 by a positive 3, we will have a minus 5. Now, let's say we didn't trust this. Minus 5 times 4x is a minus 20x. Minus 5 times plus 3 is a minus 15. So it's perfect. So now all we do, we write 9x minus 5. We write 4x and plus 3. So there we go. So we just got rid of this one right here. Yep. And we can always multiply the numbers to see if everything is perfect. So let's see. If we multiply this by this, 9x by 4x, we will get this one right here. Okay, sure about that. Then how about 9x by plus 3, resulting in positive 27x. So that's perfect. So we're done with the 9x. Let's move to the minus 5 now. Minus 5 is multiplied by a 4x, resulting in minus 20x. And then we'll move on to over here, minus 5 times plus 3, resulting in minus 15. So everything works out. Everything is perfect. All right, so we're almost 1 hour in. So I'm actually going to keep it that way. I'm actually going to keep every one of these just within an hour. I don't, unless we have like a lot of multiple choice to do. Maybe that's probably the only time I might do, you know, something a little bit longer than an hour. So let's try for the last one, 54x squared minus 87x plus 35. So let's just get to it, seeing that I want to be, you know, just shy of an hour. Well, not shy, but, you know, a little bit over it. So funny enough, I can actually undo everything or redo. So in the event that I want, see that? No, it's not magic, but it is kind of fun. I'm kind of rebuilding everything, you know. So just in case you missed it, right? So just in case I erase something, you know, so you see, a lot of people have arguments about what is better between face-to-face or online learning. And it's a give and take, right? Things are better when you have a face-to-face experience. And then there are other things you can do online that you otherwise, like when I rub off the board, like if I rub off the whiteboard, the only thing saving my students is really if I took my tablet and took the picture of the whiteboard. That's the only thing that will save them. But if it was like back in the day when we as students growing up never had the smartphone technology as to where it is today, yeah, once that board is erased, that's it. Better get that from a friend. So let's get to it then, right? Let's get to it. So we now have 54 and we have 35, and you see the 35 makes it so predictable, right? So predictable. We know what 35 is. We know what 35 is. We know what the 35 is. We know. There's no doubting what it's going to be. We know what it is. So we're not even going to waste, you know. a lot of time. So here we go. 5 times 7. Beautiful. 9 times 6, or 6 times 9. So what is 6? 6 is 2 times 3. Okay, but what is 9? 9 is 3 times 3. There we go. Now, what combination could possibly give us 87? What could give us 87? 35 times 2 is 70. Okay, so let's have a look at this. Right? We're going to try a combination, right? So we'll have 35 times 2, which is 70. So you'll have 70 and 27, which unfortunately, if you were to, well, let's also talk about something else. When you have a minus and a minus, it means that the larger number of the two was a negative number, right? Therefore, if you wanted to say minus 19 plus 12 gave you the minus 7x, then the larger number, 19 being larger than 12, not necessarily the integer itself, but just in terms of the value, right? So the value of 19 is larger than the value of 12. That number will have a negative sign. In the event that you have something looking like a minus, then a minus, right? If you have a plus, then a minus, then the situation is reversed, right? So what you will have instead is you will have the larger number with the positive, smaller with the negative, right? That's for situations like this right here. Yeah? So you can tell what you will need. A larger number being positive applies to this one. The larger number being negative, like this here, applies to this one right here, right? Just so we can make sense of what we're looking at. So that is something that I don't think I hyper focused on that as much as I could have, right? But I think it's very important to remember that. So when you see a minus, then another minus, typically the larger number is negative. And then of course, once you see it looking, wait, I'm using the wrong tool. When you see it looking like this, positive then negative, then of course the situation is reversed, right? So just to make that clear, right? So the question is, seeing that we know what gives us minus minus then plus minus, then what do we have when we have this situation over here? Meaning minus then plus. In that situation, it is the most unique out of all of them, because in that situation, you will have both signs being a minus sign. So therefore, minus, minus, when you add them, it remains negative. When you multiply them, it becomes positive, right? So I know I kind of, beat that horse to death a little bit, but yeah, that was just something that I felt like I needed to share. So therefore, because of our knowledge of this, we can only have two of these being negative. So this combination of 752 and the 333, this will not work because 70 plus 27 is 97 and it's not 87. So boy, we have to go try something else. Boy, we have to try something else. So what can we do? All right, I'm feeling a little adventurous. So let's see what would happen if, let's see if I can get it right the next time around. I am thinking of, why not 335, which is, this is going to give us 45, right? 45. What about this? 7 times, well, okay, 7 times 3, 21. 21 times 2, 42. Yes, ladies and gentlemen. Okay, honestly, I guessed. Okay? I don't want you to think that I made an educated guess. But because what I was about to do, I was going to use 3, 5, and 7. I'm not sure if I did that one before. That would have given me what? 21 times. Wow, that would have been large. That would have been like 105. Nah, that would have been too big. That would have been like the difference between 80 and 105. Yeah, that would not work. That would not work. And just imagine that. Just imagine 105 and 18. I mean, even if you were to subtract them, this would not work. Right? So I gave myself the next best option, which is 45. I thought about the 45. So now both of these numbers need to be negative. And when you add these two, you will get minus 87x. Right? So you'll get minus 87x. All right. So yes, I'm proud of this, right? Because let's be serious. If you had multiplied 54 by 35 and then you try to find the factors of that larger number, I mean, you would be sweating. You would be sweating. You would be giving yourself more work than you need to be giving yourself, right? So give me 1 second while we wait. All right, so hopefully, we stared at this long enough to remember how we got it. We did a bit of trial and error for the 54 and 35. We did a combination of the different prime numbers resulting in 3 by 3 by 5, giving us 45 up here. And then 7 by 3, 21 times 2 is 42, right? So fair enough, right? So we can erase this. And again, remember, in the event that I went too fast, I can always do this. Well, I wasn't planning to go that far, but sure. There we go. So just in case I went too far, right? So we have successfully turned minus 87x into our two numbers that combine to give us the minus 87x. So let's see how we're going to write this one now. 54, 4x squared. We have our 45x. We have our 42x. And then finally, we have our 35. All right, so let's see what we're going to do now. What was this? Minus 45? Well, it's also minus 42 because both of them have to be negative. They have to be. There's no other option. Because if you did 45 minus 42, you'd get a plus 3 or a minus 2, right? So both of them have to be positive or both of them have to be negative. So there was no alternative there. So that's the beauty of the signs. The signs can literally tell you what the numbers need to be, as well as what the signs need to be, right? So that's pretty helpful. So we are going to use some factorizing right about now. Well, this is all right. This is just obvious. When you add 45 to 9, you get 54. So it's pretty obvious that the HCF for 45 and 54 is going to be 9, right? It must be 9, right? And the HCF of x and x squared is going to be x, right? Now, this is a minus. In here will also be a minus as well. Because remember, what you get on the left, you're going to get on the right. So, all right, I didn't do the, okay, let me do it over here. Let me apologize for that. So fine, let's not take it for granted. Let's still go through the process of finding the HCF of 54 and 45. Let's do it all the same. All the same, let us get that done. So we will have 2 by 3 for 6, by 3 by 3 for 9. Now we will have 3 by 3 by 5. All right, so let's just do this. Whoops. All right, there you have it. So let us do, so 3 by 3 here. 3 by 3 here. So by doing this, we know exactly what we're going to get in here, right? 2 by 3, that's 6. So we'll put the 6 right there. But 9x times 6 is 54x and not x squared. So we'll put the x right there. Wait, hold on. Give me a second while I try to silence my dog. Okay, so that may or may not have worked. All right, so, all right, and then what's left? The 6 for up here, the 5 for down here. So let's put the 5 here. All right, that means what we have here goes over here, right? So we'll have 6x minus 5. Yeah, my 6 looks a little on the midget side over there. It's kind of weird. Looking a little on the midget side right there. All right, let's do that all over again. Let me write 6x minus 5. And let me put the brackets around that. Right? There we go. So the question is, what is plus 35 over minus 5? Well, I mean 5 by 7 over 5. There you go. Now, if this was a plus 5 over minus 5, you get minus 1. 7 over minus 1 is minus 7. So our answer is going to be, so again, if this was a plus 5 and this was a minus 5, this would have given you 7 over minus 1. Right? So what we have here is going to be minus 7. All right? So, yeah, I think we still taking my time, So let's just write everything as we know it. We'll write 9x minus 7. We'll write 6x minus 5. And then bracket here, bracket here, bracket here, and bracket here. Now let's have a look at this. 9x times 6x is 54x squared. I think everything is in order. Everything is in order. We have everything we need there. Now there is an additional step in the event that all of these equations or expressions, if they were made equal to 0, there was one final step that you would have to take. You would then have to solve for x when either side is equal to 0. Now that would be, a topic for another time. But if you're perfect doing these, then as long as the numbers that you're given, as long as they can be factorized, then you will not have a problem. Right? You won't have a problem. In fact, there's only one sign that you get that will tell you whether or not your expression can be factorized. If the third term is a prime number, but the middle term is a number that's impossible to get as a result of using the prime number at the end, then you will not be able to factorize that expression using the factoring method. You would have to use either the quadratic formula or you would have to use completing the square. Again, that is, not too far from this topic, but a little further than this. Right? So I think that's where I'll stop. Right? So again, thanks for watching. I'll see you around. And you let me know what the best time to do these lives would, I want to do these every Friday because I'm doing this during the holiday and I was just doing this to see what kind of regularity would lead to people being more available to seeing a lot of these live streams that I do. So in any case, again, thanks for watching. I'll see you around. So leave comments, you can share, right? I will drop this in my WhatsApp status. I tend to do that a lot. So if you want to watch this video again, you can do that. I'll also create a playlist, right? So I'll have a playlist for my live streams. I'll have a playlist for topics related to, multiples, factors, HCF, LCM, that sort of thing. So yeah. So anyway, I'll stop rambling. Thanks for watching, and I'll see you around.